There's a version of Albert Einstein that almost everyone carries around, and almost none of it is accurate. Not the failed math, not the isolated patent clerk, not even the socks, particularly. The story most people have absorbed, the gentle, bumbling eccentric who somehow stumbled onto not the most important physics of the 20th century, is a myth, a comfortable one, the kind that gets repeated because it makes genius feel accidental and therefore approachable. The truth is less comfortable and, I'd argue, more interesting. Einstein knew exactly what he was doing from a remarkably young age. The problems that produced the special theory of relativity had been forming in his mind since he was a teenager. He was not waiting to be discovered. He was working. That's the story we're going to follow tonight. Find a comfortable position. Let the day go if it hasn't already. We'll start at the beginning, 1879, Ulm, and work our way through to the end with all the contradictions intact. Albert Einstein was born on March 14, 1879, in the city of Ulm, in the Kingdom of Württemberg, in what was then the German Empire. His father, Hermann Einstein, was a good-natured man who ran a small feather-bed business and later a series of electrical engineering ventures. His mother, Pauline, was a pianist with a sharp mind and strong opinions. Within a year of Albert's birth, the family moved to Munich, where Hermann and his brother Jacob started a gas and water installation company and later pivoted to manufacturing electrical equipment. The house was full of wires, blueprints, generators. Albert grew up surrounded by the smell of machinery and the hum of technical ambition. His mother worried about him early. Speech came late, unusually late. He was 2, maybe nearly 3, before he said much of anything, and when he did begin to talk, he spoke in complete sentences, softly repeating phrases to himself before saying them out loud as if checking them first. It's a habit some researchers have connected to a kind of methodical, inward processing. Others have speculated about autism spectrum traits. Though this is worth flagging, retrospective diagnosis applied to historical figures is always more speculative than it looks in popular accounts. What we know for certain is that young Albert was unusual, dreamy, prone to long stretches of solitary thought, and not particularly interested in playing with other children. At 5, his father gave him a compass. This is one of the most important small moments in the history of science, even if it doesn't look like one. The needle trembled and turned, always pointing north, through glass and wood and air as if responding to something invisible. Something was there, filling the space around the compass, acting on it, real and powerful and completely unseeable. Albert couldn't stop thinking about it. He said later in life that this memory had shaken him profoundly, that the idea of hidden forces governing the visible world had seized him then and never quite let go. That compass is, in a very real sense, where general relativity began. He was a quiet child, but not a sad one. He played violin from the age of 6 because his mother insisted, and for years he resisted. Too mechanical, too much repetition, and not enough music. Then, at around 13, he encountered Mozart. He said afterward that something unlocked. Music wasn't a performance of notes, but a kind of structured thinking, an exploration of form and pattern. From that point on, the violin became what he turned to whenever the physics grew too dense or the world too loud. He played it in his study in Princeton in his 70s, eyes closed, working something through. He never needed to be a concert musician. He needed it the way some people need a long walk or the sound of rain, the sense that music and mathematics and physics were different windows into the same underlying structure. This was something Einstein felt rather than could quite articulate, and it stayed with him always. Now here's the first thing everyone gets wrong about Albert Einstein, and it's repeated so often that it has taken on a kind of cheerful urban myth quality. People love to say Einstein failed math. They bring it up whenever a struggling student needs encouragement, and the intention is kind, it really is. The problem is, it's not true, not even a little. Einstein did not fail math. He excelled at it dramatically from a very young age. By 12, he had worked through an entire textbook on Euclidean geometry on his own during a summer holiday for fun. At 13, a 21-year-old medical student named Max Talmud began having weekly dinners with the Einstein family and bringing Albert books on natural science, books on philosophy, eventually Kant's Critique of Pure Reason, and Albert read them and wanted to talk about them. By his mid-teens, he was working through calculus independently, not because anyone required it of him, but because he couldn't stop. So where did the myth come from? Two places. First, when Einstein was 16, he sat an entrance exam for the Federal Polytechnic School in Zurich. He failed, but he failed the botany sections, the zoology sections, the language sections, not the math. He passed the math portion with very high marks. He had attempted the exam 2 years younger than most applicants, without adequate preparation in the humanities subjects, because he was trying to rejoin his family in Italy, where they had relocated without him. Less a failure than a miscalculation of timing. Second, the Swiss grading system uses a scale where 6 is excellent and 1 is failing, the opposite of some German systems where the scale runs the other direction. Some early accounts of his transcript were read backwards, leading people to interpret his top math marks as terrible. The myth was born partly from a translation error and partly from the very human desire to believe that genius is accessible to everyone. What's worth understanding about this, and I think it actually matters, is that the myth persists not because it's plausible on its face, but because it satisfies something emotionally. We want there to have been a flaw. We want the greatest physicist of the century to have struggled with the most basic thing. It makes the story feel fair. The truth, that he was doing calculus alone at 15 and dismissing his professors as too slow, is less comforting but considerably more accurate. And the fact that the myth survives, despite being easily checked, tells you something about what we need from this story more than it tells you anything about Einstein. His professor, Hermann Minkowski, called him a lazy dog. That line gets quoted a lot. It's worth noting this is the same Minkowski who would later use Einstein's own theory of special relativity to develop the concept of four-dimensional space-time. Einstein was apparently untroubled by the criticism. He had stopped going to Minkowski's lectures. He graduated from the Polytechnic in 1900, 4th out of 5 students in his cohort in physics. And then came a period that really was difficult, genuinely difficult, the kind that reshapes a person. He needed an academic position. He applied for several. He got none. The professors whose lectures he had skipped, whose authority he had refused to defer to, they wrote the kinds of letters that closed doors quietly. One professor told him flatly that his academic future was finished. He gave private tutoring lessons. He got fired from 2 of those as well. For a young man who had been certain since childhood that he had something real and important to say about how reality worked, this must have been a particular kind of torment. Not poverty exactly, but professional suffocation. A door he could see but not open. Then a friend's father intervened. Marcel Grossmann, one of Einstein's closest friends from his Polytechnic years. a man who had shared his careful lecture notes with Albert so he could study from them instead of attending class. Grossman's father knew Friedrich Haller, the director of the Swiss Patent Office in Bern. A word was spoken. In 1902, Einstein began work as a technical expert, third class, evaluating applications for electromagnetic devices. And here's the second great myth about Einstein, almost as persistent as the failed math story. The myth is that the patent clerk job was a dead end, a consolation prize, that Einstein was wasting away in obscurity, his genius dormant, waiting to be rescued by the world. The reality is more elegant and also more instructive about how good ideas actually develop. He had already built by his teenage years a practice he called thought experiments, Gedanken experiments in German, not lab work, not calculation yet, but pure imaginative reasoning. Picture a physical scenario, follow its logic with complete rigor, see where it leads. One of the most famous, what would it look like to ride alongside a beam of light? If you traveled at the speed of light and looked at a light wave traveling beside you, it should appear stationary to you, a frozen electromagnetic oscillation hanging in space. But Maxwell's equations allowed for no such stationary solution. Light always moves at the same speed. Something was wrong. A teenager in a classroom in Aarau was quietly turning this paradox over in his mind. It would take him 10 years to resolve it. When he did, the resolution was special relativity. A patent examiner for electromagnetic devices in 1902 was not a mailman. He was a technical specialist whose job was to read and evaluate the cutting edge of applied physics. The applications flowing across Einstein's desk were about signals, clocks, the transmission of light, the synchronization of distant timepieces, the very questions at the center of physics in that era. How do you coordinate two clocks that are far apart? How do you know they're showing the same time? What does it mean for two events to happen simultaneously if they are separated by distance? These were engineering problems landing on his desk every day, and as his mind processed the patent applications, accepting some, rejecting others, noting the flaws in each, it was also working through the deeper questions underneath them. What is time, actually? What does it mean to say something happens at a certain moment? Can two observers ever fully agree on when something occurred if one of them is moving? This is the point I want to sit with for a moment, because it gets lost in the struggling genius narrative. The patent office didn't delay Einstein's work. It almost certainly shaped it. The questions he was being paid to evaluate were the questions he was privately obsessed with. That's an unusual alignment. Most scientists have to fight their circumstances to do original work. He happened to work inside his. He had a close friend in Bern, Michel Bessot, a mechanical engineer, a warm and generous thinker with whom Einstein would walk and argue and turn ideas over. Bessot was important. He was the only person Einstein thanked by name in his 1905 special relativity paper. Not a professor, not a mentor, a friend who walked beside him and listened and pushed back. When Einstein later described how he'd finally broken through on a problem he'd been struggling with for years, he said he'd discussed it with Bessot one afternoon, and the next morning he woke up with the answer. Whatever exactly was said in that conversation, we don't have it. The letter that mentions it survives. The content of the conversation doesn't. And so we arrive at 1905. This is the year that makes everything else in the story worthwhile. Einstein was 26 years old, recently married with a newborn son. He was still working at the patent office. By any conventional measure, no institutional affiliation, no laboratory, no graduate students, no prestigious position, a nobody. Between March and September of 1905, he submitted 4 papers to Annalen der Physik, the leading physics journal in the world. 4 papers, 6 months. Any one of those papers would have been enough to establish a serious scientific career. Together, they are the most concentrated burst of theoretical discovery by a single person in the history of modern physics. Physicists call 1905 his annus mirabilis, his miracle year, and that Latin phrase, which just means miraculous year, still doesn't quite capture the scale of what happened. The first paper was on the photoelectric effect, the observation that when you shine light on certain metals, it knocks electrons loose, and the number of electrons released depends not on the brightness of the light, but on its frequency. This was deeply strange and deeply troubling to the physics of the era. It made no sense under the wave theory of light, which had dominated for a century and had overwhelming experimental support. Einstein's explanation was radical. Light, he proposed, sometimes behaves not like a wave, but like a stream of discrete particles, each carrying a fixed packet of energy. He called these quanta. We now call them photons. This paper, not the relativity papers, not E equals mc squared, this paper was what earned Einstein the Nobel Prize in Physics in 1921. Planck himself, who had introduced the idea of energy quanta in 1900 but had not applied it directly to light, was uncomfortable with Einstein's extension. He thought it was a step backward. He was wrong, but his discomfort is understandable. What Einstein was proposing cut against a century of careful, elegant science about the nature of light. The second paper explained Brownian motion, the strange, jittering movement of tiny particles suspended in liquid that had been observed under microscopes since the early 19th century. Einstein gave it a precise mathematical treatment, demonstrating that the motion was caused by the invisible, constant bombardment of molecules. This paper effectively proved the existence of atoms, not just as a useful theoretical construct, but as actual physical objects. There were still serious scientists in 1905 who doubted that atoms were real. After this paper, the debate was essentially over. The third paper is the one that rewired the universe, on the electrodynamics of moving bodies, published September 26, 1905. The special theory of relativity, and it is remarkable in many ways, including the fact that it contains not a single footnote and references only 5 other scientists. Einstein was working from first principles, from thought experiments, from the kind of deep imaginative reasoning he had been practicing since the compass needle trembled in his 5-year-old hand. The core of special relativity rests on 2 postulates. First, the laws of physics are the same for all observers moving at constant velocity relative to each other. Second, the speed of light in a vacuum is the same for all observers regardless of the motion of the light source. These seem simple. Their consequences are anything but. If the speed of light is constant, then time itself cannot be. 2 observers moving relative to each other will not agree on how long events take, or even on whether 2 events happened simultaneously. Time slows for moving objects. Space contracts. Mass and energy are different expressions of the same thing. The universe, it turned out, was not what Newton had described. Space was not a fixed stage on which events occurred. Time was not a universal river flowing at the same rate for everyone. They were relative, dependent on the observer, interwoven, flexible. The cosmos was stranger and more beautiful than anyone had imagined. And the fourth paper gave the world E equals mc squared, mass times the speed of light squared. An object at rest contains an almost incomprehensible amount of energy locked inside its mass because the speed of light is already enormous, and you're multiplying mass by that number and then by itself again. A tiny amount of matter contains a staggering amount of energy. This was not just a theoretical curiosity, it was the equation that would, decades later, change geopolitics and rewrite what it meant to be at war. 4 papers, 6 months, a patent office in Bern. Worth noting, those papers were largely ignored at first. not rejected, not criticized, ignored. The physics establishment was not watching for a junior examiner from Bern. The first real engagement came from Max Planck, who assigned his assistant, a young physicist named Max von Laue, to study the relativity paper in detail. Von Laue was so impressed that he traveled to Bern to meet this Einstein. He arrived at the patent office and asked for Dr. Einstein. The receptionist pointed to a young man across the room. Von Laue assumed there had been some mistake. He had expected a distinguished professor. What he found was a junior clerk in his mid-20s who looked up from a patent application and smiled. That meeting must have been something. Von Laue later described his astonishment. Einstein, apparently, was quite calm about the whole thing. The world was beginning to come to him. Slowly at first, then faster. In 1909, Einstein left the patent office, accepting a university position. Then another still, each more prestigious than the last. By 1914, he was in Berlin at the Kaiser Wilhelm Institute of Physics, the most prominent scientific position in the German-speaking world, elected to the Prussian Academy of Sciences. 12 years from rejected job applicant to the summit of European physics. But things were not quiet inside his life during those years. And here we arrive at a part of the story that is genuinely uncomfortable and worth understanding because it's part of who Einstein actually was. He had married Mileva Maric in 1903. She was a Serbian physicist, sharp, methodical, deeply serious about her work, and she was the only woman in the physics program at the Zurich Polytechnic when they met. They had fallen in love slowly through years of study and correspondence, their letters full of jokes and physics problems and tender affection. They had a daughter together before they were married, a girl named Lieserl, whose fate remains uncertain. Most historians believe she died of scarlet fever as a toddler, though the evidence is incomplete and the story of her brief life has never been fully resolved. Then they married and had 2 sons, Hans Albert and Eduard. The question of whether Mileva contributed to Einstein's early scientific work, particularly the 1905 papers, is genuinely contested among historians, and the records here are messy in ways that make clean conclusions difficult. She referred in a letter to a friend to work they had finished together that would make her husband world famous. He used the word "our" in early correspondence when discussing theories. Her marks in applied physics at the end of their degree were actually higher than his. Some researchers argue these references are compelling evidence of real collaboration. Others, including the editors of the collected Einstein papers, maintain that the language reflects emotional closeness more than scientific co-authorship, and that nothing novel can be attributed to her with certainty. I'd be careful about resolving this too confidently in either direction. The letters that survive are suggestive but not conclusive. What we can say is that she was a trained physicist capable of the work, that she was in close intellectual contact with Einstein throughout the period in question, and that we simply don't have the documentation to settle it definitively. The honest position is that we don't know the full extent of her contribution, and anyone who tells you they do is working past the available evidence. What is not contested, Mileva gave up her own scientific ambitions. She stopped pursuing a degree, managed the household, raised the children, and watched her husband become famous while she remained almost entirely unknown. And Einstein, brilliant, publicly eloquent about justice and human dignity, treated her badly, not dramatically, not in some single devastating act, steadily, coldly, over years. By 1912, he had begun an affair with his cousin, Elsa Lowenthal. In 1914, when the family moved to Berlin for his prestigious new post, Mileva and the children were essentially left behind. Einstein drew up what historians have described as a remarkable document, a list of conditions he expected Mileva to obey if she wished to remain in the household. Among them, she was to provide him 3 meals a day, keep his study clean, refrain from any personal communication with him unless required, and not expect any emotional closeness from him in return. He signed it as if it were a business agreement. She left. She took the boys back to Zurich. They divorced in 1919, with a clause in the agreement stating that if Einstein ever won the Nobel Prize, she would receive the money. He did win in 1921, and he honored the agreement. She received the prize money, bought apartment buildings in Zurich, and spent the rest of her life caring for their younger son, Edward, who had been diagnosed with schizophrenia and required costly institutional care. She died in 1948. Edward remained in institutions until his death in 1965. Einstein married Elsa in 1919, the same year as the divorce, the same year as the solar eclipse. This is, I think, the part of the story that keeps it from being comfortable. A man can genuinely care about justice in the abstract and be unkind in the particular. A man can see the curvature of space-time and miss what is right in front of him. These things coexist in the same person. His eldest son, Hans Albert, once said, with a kind of weary precision, that the only project his father ever gave up on was him. November 1919, the announcement that changed everything. A packed meeting room at the Royal Society in London. The war had ended just a year before, and the wounds between nations were still fresh. On the stage, astronomer Frank Dyson announces the results of 2 expeditions mounted by the British Royal Observatory. One to Sobral in Brazil, one to the island of Principe off the west coast of Africa, that had traveled there to photograph a solar eclipse on May 29th, 1919. The purpose of those expeditions was to test something Einstein had predicted 4 years earlier with his general theory of relativity, published in full in 1915. General relativity was the larger, deeper, more difficult successor to special relativity, where special relativity described what happens in systems moving at constant velocities. General relativity described what happens when things accelerate, and it reconceived gravity entirely. Newton had treated gravity as a force, something that acted instantaneously across empty space between massive objects. Einstein said, no, gravity is not a force. Mass warps the fabric of space-time around it, and other objects follow the curves. The Earth doesn't orbit the sun because the sun is pulling it. It follows the curvature that the sun's mass creates in the structure of space and time itself. Think of space-time as a stretched rubber sheet. Place a bowling ball in the center and the sheet dips. Roll a marble nearby and it curves toward the bowling ball, spiraling inward, not because the bowling ball reached out and grabbed it, but because the marble is simply following the curve of the surface. That's gravity in general relativity, not a pull, a curve, a geometry. Reality at the largest scales is not a stage on which events occur, but a dynamic, flexible medium that participates in everything happening within it. Einstein had completed the mathematical framework for general relativity in November 1915 in a period of extraordinary intensity. 4 papers submitted on successive Thursdays to the Prussian Academy of Sciences, each one correcting and refining the previous, the final one containing the field equations in their full form, 10 coupled non-linear partial differential equations, some of the most complex ever written by a human hand, describing how matter and energy shape the curvature of space-time and how that curvature shapes the motion of matter and energy. He compared finishing those equations to a dream that had finally resolved itself. he said he was beside himself with joy. The test of the theory was elegant in its simplicity. Light should bend around massive objects because light follows the geometry of space-time, and massive objects curve that geometry. During a solar eclipse, you could see it directly. The expeditions found exactly that shift. Light bent by precisely the amount Einstein's equations predicted, not Newton's amount, which would have given a smaller deflection, Einstein's amount. Dyson stood before the Royal Society and announced it. The next morning, the Times of London ran the headline, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." Before November 8, 1919, Einstein's name had never appeared in the New York Times. After that date, there was not a single year until his death that it did not appear there. A German theoretical physicist, in the aftermath of a devastating world war between Germany and England, had his work confirmed by British astronomers and was immediately celebrated as an international hero of science. The timing was not incidental. Science wanted to show that it belonged to everyone, that discovery transcended nationalism. In that particular historical moment, Einstein was exactly what the world needed. He stepped into that role and became something science had never quite produced before: a celebrity scientist, a mass media phenomenon. He traveled the world giving lectures in Japan, the United States, South America, Palestine. And wherever he went, enormous crowds arrived. Not because they understood the theory of relativity, but because he had become a symbol of human intelligence, of the possibility that a single remarkable mind could change the way we understand reality. He found it occasionally amusing and frequently exhausting. Through the 1920s, Einstein wrestled with what would become the great defining tension of his later career. He had helped invent quantum mechanics. The papers of 1905, the photoelectric effect, the explanation in terms of quanta, had planted the seed, and he had done more than that. In 1917, he derived the mathematics of stimulated emission, the process by which an incoming photon triggers an atom to emit an identical photon, both photons then traveling together. This quiet result was largely ignored for decades. In 1960, it became the physical foundation of the laser. Every laser pointer, every barcode scanner, every surgical laser in every hospital on Earth runs on that 1917 derivation. Einstein received no particular recognition for it during his lifetime because no one yet knew what to do with it. In the years that followed, Heisenberg, Bohr, Born, Schrödinger, and others built on the quantum foundation and produced a strange, counterintuitive, astonishingly successful theory of how matter and energy behave at the smallest scales. Quantum mechanics said that at the quantum level, particles don't have definite positions and velocities at the same time. You can know one precisely only at the cost of the other. The universe, at its foundations, is fundamentally probabilistic. Things don't happen for definite reasons. They happen with certain probabilities. God, as the famous shorthand goes, plays dice. Einstein hated this, not the math. The math worked beautifully, precisely, better than almost any physical theory before or since. He knew that. What he hated was the interpretation, the idea that the universe was, at its bedrock, random, that there was no underlying reality, no hidden variables, no deeper clockwork beneath the quantum foam. He believed, felt, with the same conviction he had felt since the compass needle trembled in his 5-year-old hand, that the universe was orderly, that God did not play dice. He and Niels Bohr argued about this for years, at conferences, in letters, in long conversations that both men found simultaneously maddening and deeply valuable. Bohr was warm, patient, and absolutely certain that quantum mechanics was complete, that there was no deeper layer, no hidden variables, no way to resolve the uncertainty. Einstein kept arriving at conferences with new thought experiments designed to expose a flaw. Bohr kept answering them one by one. The argument never ended. It couldn't. They were operating from different intuitions about what physics was supposed to explain. Here is the thing that strikes me about that debate. It is often told as Einstein being on the wrong side of history, the stubborn old man who couldn't accept the new science. That framing misses something important. His objections weren't wrong because he was failing to understand quantum mechanics. He understood it better than almost anyone alive. They were wrong because his intuition about what reality must be like turned out not to match what reality actually is. That is a different kind of being wrong. It's also a more interesting kind. He wasn't confused. He was insisting on something the universe simply didn't owe him. What's remarkable, looking back, is that both men were brilliant beyond almost any measure, and both were, in different ways, right and wrong simultaneously. Bohr was right that quantum mechanics is complete as a predictive framework. Einstein was right that it raises profound, unresolved questions about the nature of reality that physics is still wrestling with today. He spent 20 years developing thought experiments designed to expose flaws in quantum mechanics' philosophical foundations. The most famous came from a conversation at Princeton in 1935, a paper written with Boris Podolsky and Nathan Rosen, known today as the EPR paper. It described what Einstein called spooky action at a distance. If two particles interact and then fly apart, measuring the state of one instantly determines the state of the other, no matter how far apart they are, even across the width of the galaxy. This, Einstein argued, proved that quantum mechanics was incomplete. There had to be some underlying information, some hidden variable that explained the correlation without requiring information to travel faster than light. He was wrong about the conclusion. Decades of experiments since his death have confirmed that the spooky action is real, that quantum entanglement works exactly as the theory predicts, that there are no hidden variables. What Einstein thought was a reductio ad absurdum, an argument so strange it must disprove the theory, turned out to be simply the truth. The universe is genuinely stranger than he could accept. But the EPR paper was still important. It didn't disprove quantum mechanics. It revealed something profound about it, what we now call quantum entanglement, that has since become one of the most active areas of physics research and is the foundation of quantum computing. Einstein was wrong about what it meant and right that it mattered. That combination, right that something is important, wrong about what it implies, is a very human kind of being brilliant. In January 1933, Einstein was visiting the United States when Adolf Hitler was appointed Chancellor of Germany. He never went back. He had seen what was coming for some time, had watched the rise of anti-Semitic violence with the particular clarity of someone who had been its target. His work attacked publicly as Jewish physics, as a conspiracy against real German science. He had already been moving his most important papers out of Germany quietly. When the Nazis came to power, his property was seized, his name appeared on lists. He was formally an enemy of the state. He accepted a position at the newly established Institute for Advanced Study in Princeton, New Jersey, a place designed to be exactly what its name said, a place where scholars could think, free from teaching obligations, free from administrative demands, free from the immediate. Einstein described it as a haven. He moved into a house at 112 Mercer Street in Princeton and made it his home for the rest of his life. Princeton was a small, quiet town, the kind of place where he could walk in the morning without being immediately recognized, at least at first. The Institute had no required curriculum, no mandatory lectures, no bureaucratic demands on its members' time. Einstein arrived when he felt like it. He sat and thought, he wrote, he walked home for lunch, he went back, he walked home again in the afternoon, often stopping to help children with their homework when they stopped him on the street. Small kids holding math problems out to the most famous physicist in the world, and he helped them cheerfully, unhurriedly, treating the problems with the same careful attention he gave to the field equations of general relativity. He was, by most accounts, genuinely kind to strangers, warm, funny, accessible, carrying no trace of the status that had accumulated around him. It was the people in his actual life, the ones who needed consistent emotional presence rather than occasional warmth, who got the harder version of him. And there he worked, every day, steadily, walking to the Institute through the quiet streets, walking home again. He grew older. Elsa died in 1936. His younger son, Edward, remained in a psychiatric institution in Switzerland, and Einstein, who had left Europe and could not easily return, sent what money he could, but could not visit. His relationship with Hans Albert was better, but still strained. He walked with his friend Kurt Gödel, the mathematician, both of them among the most singular minds of the 20th century, discussing physics and philosophy along the paths of a quiet New Jersey town, and he worked on the unified field theory, the attempt to reconcile general relativity with quantum mechanics, to find a single set of equations that described all the fundamental forces of nature in one coherent framework. He worked on it for 30 years. He never found it. It remains the deepest problem in theoretical physics today, pursued now by thousands of physicists using tools Einstein never had. Some colleagues were gently, occasionally less gently, unkind about this. Younger physicists thought he had become isolated, stuck, unwilling to accept the world quantum mechanics had revealed. There was truth in that. I don't think it makes him a tragic figure exactly. He chose to spend his remaining years on the hardest problem rather than consolidate what he had already done. That is a choice you can disagree with, but it doesn't require an apology. He had a 1,500-page FBI file compiled by J. Edgar Hoover, who considered him a dangerous radical, monitoring his phone calls, opening his mail, rifling his trash, his left-wing views, his advocacy for civil rights, his public statements against nuclear proliferation, all of it read in the McCarthy era as subversive. He was not a communist, but he was not apologetic about believing that governments and scientists alike had responsibilities to human beings rather than to power. He joined the NAACP. He corresponded with W.E.B. Du Bois. He saw the parallels between the treatment of Jewish people in Germany and the treatment of black people in America with a directness that many of his colleagues avoided. He wrote publicly that racism was America's worst disease. He was offered the presidency of Israel in 1952 and turned it down. He said he lacked the natural aptitude for dealing with people in official functions, which is probably accurate. He had played some role, indirect but real, in the creation of the atomic bomb. In 1939, Leo Szilard, a Hungarian physicist gravely worried about Nazi Germany's nuclear research, went to Einstein and convinced him to sign a letter to President Franklin Roosevelt. Einstein was a pacifist by instinct and conviction, but the prospect of nuclear weapons in Hitler's hands was a different kind of problem than ordinary war. He signed the letter. It alerted Roosevelt to the possibility of a nuclear chain reaction and urged the United States to accelerate its own research before Germany could achieve it. The Manhattan Project followed. Einstein was denied the security clearance required to work on it directly. His politics were considered too risky, so the project that his E equals mc squared had made conceptually possible proceeded without him. When the bombs fell on Hiroshima and Nagasaki in August 1945, Einstein said simply, "I could burn my fingers that I wrote that first letter to Roosevelt." He meant it. He spent the rest of his life calling for international control of nuclear weapons, for disarmament, for a world government capable of preventing another war of that scale. He signed the Russell-Einstein Manifesto in 1955, just before his death, calling on the nations of the world to seek peaceful resolution of disputes in the nuclear age, one of his last public acts. He was not the father of the bomb, as he himself said clearly, but he could not fully escape its shadow. He didn't try to. In the spring of 1955, the aortic aneurysm that had troubled him since 1948, a bulge in the main blood vessel of the abdomen, surgically reinforced once but never resolved, began to fail. On April 13th, doctors recognized that a rupture was imminent. They told him surgery might help, they said. It might not. He refused. He had already worked through this in his mind. When doctors had first found the aneurysm in 1948, he had said, "Let it burst." When it came to it, his answer was the same, and equally calm. He did not want to live longer through artificial means. He had done his share. He wanted to go when he wanted to, and he wanted to do it elegantly. He was moved to Princeton Hospital. At his bedside were notes. He was still working, still trying in those last hours to close the gap between general relativity and quantum mechanics, to find the thing that had eluded him for 30 years. The nurses said he muttered in German as the night passed. The nurse on duty did not speak German. No one knows what he said. At 1:15 in the morning on April 18th, 1955, Albert Einstein died. He was 76 years old. He had asked to be cremated. He had asked that his ashes be scattered in secret, so that no place would become a shrine. His body would not be buried. His grave would not be visited. He did not want to be an idol. The pathologist on duty that night, a man named Thomas Harvey, performed the autopsy and determined the cause of death was the ruptured aneurysm. And then he did something that Einstein would have loathed. He took the brain, not with permission, without authorization, without any signed consent. Harvey removed Einstein's brain, severed it from the body, and took it home. He later persuaded Einstein's son, Hans Albert, to give a retroactive blessing for keeping it for scientific study. But the executor of the estate, Otto Nathan, was furious. Einstein had wanted no idols. He had wanted to be scattered. And here was his brain sitting in a jar. Harvey stored it in a cider box. He stored it in a beer cooler. He took it with him when he moved from Princeton to the Midwest, carrying it in his car across the country. He lost his job at Princeton Hospital for refusing to return it. He spent decades promising he was 1 year away from publishing a groundbreaking study of what made the brain special. He never published it. He never had the expertise to analyze what he had stolen. Eventually, he returned what remained to the family, who donated the microscopic slides to the Mutter Medical Museum in Philadelphia, where they remain. Harvey meant, in his strange way, to honor Einstein. He failed. He honored himself instead, and gave Einstein exactly the kind of morbid posthumous celebrity Einstein had explicitly requested to avoid. The last words, lost to history in German, the brain on slides in a Philadelphia museum, the equations as relevant as the day they were written. What do you do with a life like this? Because it is not tidy. It is not the story of a gentle old eccentric who loved sailing and played violin and smiled for the cameras. All of that was true, genuinely true. He did love sailing, badly and joyfully, crashing into things with serene indifference. He did play violin his whole life, treating music as the other half of his thinking. He did have an extraordinary warmth with strangers and a talent for mischief that people who met him as an old man in Princeton still talked about decades later. He liked crude jokes. He liked not wearing socks. He once told a room full of distinguished scientists that if he had known his work would lead to nuclear weapons, he might have become a watchmaker instead. The room laughed uneasily. He wasn't entirely joking. All of that was real. And also, he was a difficult husband, a frequently absent father, a man who could write beautifully about the dignity of all human beings, while treating the particular human beings in his household as inconveniences. He spent the last 3 decades of his professional life on a project that went nowhere, refusing to fully embrace a theory, quantum mechanics, that the rest of his field had accepted and was using to reshape technology, medicine, and our understanding of matter itself. He signed a letter that helped set in motion the development of the deadliest weapons in human history, and lived with that knowledge until his last breath. He also, and this part gets left out of almost every account, genuinely cared about politics and justice in ways that cost him socially and professionally. He spoke publicly about racism in America at a time when very few white public figures did. He wrote to Du Bois. He called segregation America's original sin. He gave speeches that J. Edgar Hoover cataloged in a growing file. He wasn't performing virtue. He saw what was there and said what he saw, even when it was inconvenient, even when it attracted surveillance and suspicion. He was enormous and flawed. The flaws don't diminish the enormity. The enormity doesn't excuse the flaws. That is not a comfortable conclusion, but it is an honest one. His legacy is everywhere in ways most of us encounter without knowing it. GPS satellites require corrections for the effects of both special and general relativity. Without those corrections, built into the software of every satellite in the network, the positioning errors would accumulate at a rate of kilometers per day. Every time you use a map on your phone, Einstein's equations are running underneath. The lasers in your DVD player and barcode scanner rely on the understanding of stimulated emission that Einstein developed in 1917. The nuclear reactors that generate electricity in dozens of countries are expressions, ultimately, of E equals mc squared. Gravitational waves, ripples in the fabric of space-time itself, caused by the collision of black holes and neutron stars, were directly predicted by general relativity and directly detected for the first time in 2015, 60 years after his death, by the LIGO experiment. The image of a black hole captured in 2019 by the Event Horizon Telescope matched Einstein's predictions precisely. And then there is quantum entanglement, the phenomenon he called spooky action at a distance. The thing he believed proved quantum mechanics was incomplete. It turns out to be completely real. Scientists have used it to build quantum cryptography systems that are theoretically unbreakable. They are building quantum computers that use entangled particles to perform calculations that would take ordinary computers longer than the age of the universe. The technology of the next 50 years may be built on the experimental confirmation of the thing Einstein most wanted to disprove. History has a sense of humor that way. He saw all of this coming in rough outline, and he didn't live to see most of it confirmed. He would have found it satisfying that the search continues. He would have been unsurprised that the universe keeps revealing itself to be stranger than anyone expected. Let the quiet settle around you as the night does what it does. Looking at the whole arc of the life, what strikes me is not the brilliance. The brilliance is almost beside the point after a while, because the output speaks for itself. What's interesting is the stubbornness, the compass at 5, the thought experiments at 15, the 30 years spent on a unified field theory that didn't yield, the refusal to accept quantum mechanics implications even as the evidence accumulated, the refusal of the surgery at the end. There is one trait running through all of it. He trusted his own sense of what the universe should be like, more than he trusted the world's consensus, more than he trusted the people around him, more than almost anything else. That worked extraordinarily well in physics. It cost him in other places. He said once that the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. He never stopped believing that, not for a day. Not until those last murmured words in German that no one could hear and no one will ever know. Whatever he said, we don't have it. What we have is the equations, the satellites, quietly correcting for the curvature of time, the black holes bending light exactly as he said they would. That's enough to carry into sleep. If tonight's journey through the life of Albert Einstein gave you something to carry, a question, a thought, a small new wonder at the strangeness of reality, then leave a like and consider subscribing to The Sleepy Biographer. It takes time to build these stories, and every subscriber means another person drifting off with a little history in their pocket. Good night.